On the screen.
Good morning, one and all from India. This is day 3 of IVWGST of what has been intriguing journey of knowledge sharing and integration from the finest mind of the world. I thank each one of you for attending the event in large numbers and would like to request to sustain the encouragement. The keynote speaker for this session is Professor Alan Kafka from Boston College of USA. Alan, thank you for accepting our invitation in order to deliver a talk. Moreover, I'm indebted to you as you had to start your day pretty early as it is 12 a.m. in Boston now. The title of your lecture is Reflections on My Past 2 Decades of Teaching Geoscience and Public Policy, an undergraduate science course for non-science major. I'm particularly excited for this as it is altogether dwells on a very different aspects of geosciences and its perception. So it further adds to the diversity of knowledge and experience emanating from the different sessions of IPW GST 2021. Now, before we start the session, may I request our session chairman, Professor J.R. Kyle, to say a few words. Over to Professor J.R. Kyle, sir.
Thank you, Shantanu. Good evening to Professor Kafka, who is from USA, and we are so lucky to have you to this forum. We really look forward to listening to your very interesting talk today. So thank you so much for kindly accepting our humble invitation. And we again warmly welcome you, and we all really eagerly waiting for listening to you. Thank you so much. Over to Shantanu.
Thank you, sir. Now, may I read out a summarized biodata for Professor Kafka in the following lines. Professor Kafka is presently serving as an associate professor of art and environmental sciences at Boston College since 1989. Dr. Kafka is also the director of Western Observatory, Boston College since 2013, and the founder and facilitator of Boston College Educational Seismology Project since 2004. The prime interest of Professor Kafka include geophysics, earthquake science and environmental science, science education and communication, citizen science for the public good, amongst others. He pursued MS in applied mathematics from Stony Brook University in 1973 and thereafter completed his PhD in 1980 from the same university. Professor Kafka has published more than 60 papers in reputed journals, including Science. He is also an associate editor of Seismological Society of America. That was a very brief and concise introduction of Professor Kafka. Thank you, Professor, for accepting our request to be one of the keynote speakers. The time is all yours now. Thank you. About to Professor Kafka.
Hi. So I want to start by telling the meeting organizers how grateful I am that you endorsed the topic that I'm going to be speaking about. And I say that because I know from reading the Eduquakes paper that you published on the 2020 version when you had to very quickly change over to remote, I know, and from that and from looking at the agenda that you have now, that many of his talks are, most of the talks are technical scientific areas of expertise from great people who can teach us about all the different what's happening in seismology research, statistical seismology, internal structure of the earth. These are great things, and I'll say a couple words about that as I go along. But excuse me, this is something a little bit different, and I think I thought it would round off the topics by sort of talking about the topics. So I'm grateful that you said yes and are allowing me to spend the next half hour, 45 minutes presenting this. I'm hoping that this will turn into a discussion and that I don't absorb too much time. My point here, however, it could be quite short. It could be all the way up to the 45 minutes, is to motivate some discussion. So with that, let me move forward. So I don't know, this is a cultural reference that you may or may not be aware of. It's one of the first and most famous album from the Beatles, and they started the song in one of their first big albums with the words, "It was 20 years ago today." So I will leave you to decide whether that's something you remember or not. It's from my childhood, and I don't need to say anything more about that. I will go on with the content of my presentation. So it was 20 years ago. I tried to trace down when this happened. I saw it in the 1999 2000 college catalog that I was teaching it. So maybe I taught it the year before, so it might be 21 years, but it was about 2 decades ago.
Pardon me,
And
sir. Sir, are you sharing your slides? It's coming on black. Really.
say that again?
Your sharing content is coming totally black, sir. Can you reshare it again?
Let me try to do that. So need to figure out how to do that.
You can close it up once and reopen it if you.
Okay, I did stop sharing.
Yes,
And
sir.
now
You
I'm
can
going to say,
reshare it.
now I'm going to share it again. Except that now, how's that? You see it?
No, sir.
You see it now?
No, sir. Actually, I can't see it.
What do you recommend? It was working a few minutes ago when we tested it.
Yes, sir. You can actually close the slides and try to reopen it.
Reopen the PowerPoint?
Yes, sir. Yes, sir.
Let me find the PowerPoint. I'm going to start the PowerPoint again.
Okay, sir.
Hold on. Do you see a PowerPoint on the screen?
You have to share it, sir. Okay.
Right. Okay, so I opened it. Open share tray.
Now select the window, sir.
How's that? See it?
No, not yet, sir.
Hmm. You don't see it. I'm sharing the screen. That's unfortunate. Did you see it at all from the beginning? Did the participants see it at all from the beginning? What about I send it to you as an email and you show it?
Okay,
Yes,
sir.
yes,
That
yes.
will be fine.
Don't you think that'd be safer at this point? Let me do that.
Yes, sir. Please say it, sir.
Will I be able to flip through it, or should I just say next slide?
Okay, sir. We can pick it up for you.
So which one of you should I send this email to?
So please send it to sourcetalk.ph.
Say that again.
Sourcetalk, SAUS.
SAUS.
Hello, Alan. Please send it. Please send it to me. It will save your time. Please send it to me. I can forward it immediately.
So which address?
Santanu.
Okay.
Yeah, Santanu. Yeah.
Okay. I'm going to do that. I'm just going to call it slides. Okay. And I need to find it. Okay, I'm sending it. Didn't click send.
Send it to me. Santanu.
Right now.
Yeah. Let me see. It has not arrived yet.
How about that?
Not yet received.
Got it?
Not yet.
I sent it. I guess I should try to send it again.
Yeah, please. We did not receive anything till now.
I'm going there.
Please.
Hold on. Okay. Trying it again.
Yeah.
Sent it.
Yes, another.
Not yet, huh?
Not yet.
Because it's a big file, I bet.
A big file. That's right.
So I guess while we're doing that, I should try to open it again.
Please. Yes, please.
What do we think is going on here?
Hello, we received. Hello.
Good.
Yeah, we received, and I'm forwarding it to Gautam and Susto, and they'll
And so
immediately.
you think I'll just be able to speak from there?
Yeah, you can speak. Yeah.
Okay. And will I see it?
Yeah, Gautam and Susto, please check your email. Gautam.
Say it again?
Yes. So your screen is coming on. If you want, you can share your PPT on desktop.
What should I do?
Gautam.
Yes.
Gautam.
You can open your PPT, sir. Yes, I'm checking our emails.
Hello, Gautam.
Yes, Santunda.
I have sent already an email to you. Please check it. Also, Susto.
Yes, I'm downloading.
Please download it.
I'm seeing a screen with a lot of initials on it. Is that what I should be seeing?
Okay, sir, let me share on behalf of you. I have received the slide.
Mm-hmm. Mm-hmm.
So please do inform me when you want me to change the slide. Right now it is in reflection on my past 2 decades, the title slide, first slide.
So I can't see that, but hold on. I think I have a plan here. Bear with me. Can you see the title slide?
Yes, sir.
Okay, so did you heard me speaking, right? You just didn't see the slides?
So I have shared the presentation on my desktop, from my
Yeah.
desktop actually. So it is on the first slide.
Okay. So
So whenever
and
you want me to change the slide, you can just tell me. I will change the slide. That will be taken. That will take effect.
mhm. Okay. Next slide. So did you hear me speaking about? Okay, so I'm going to hear. All right. So here's my story. We are, if you could click again to get where it says about 20 years ago.
That's right, sir.
Yeah. So what happened was that about 20 years ago, I was teaching all of my courses and teaching some kind of standard seismology and geophysics. And I had an opportunity to teach a course for non-majors, any course that I would want to. And so I thought about it for a while, and I thought I will expand my horizons, and I would teach a course called I teach a course on the intersection of Earth systems and society. And I don't know what other people's experiences were, but in my experience, this was not done a whole lot 20 years ago. That we're hearing a lot more about teaching and doing citizen science and connecting Earth systems with society. So it was all very new to me, and I decided that I was going to call the course Geoscience and Public Policy. Click again, where it says March for Science.
Yes, sir. Geoscience and public policy.
Click again. It says
March
March for
for science.
Science. Yeah, okay,
Yes, sir.
thank you. Yeah, we're just going to do it this way. All right, so fast forward to today, and it's it's kind of sad to me that I thought back 20 years ago we were going to all march forward with science and society, and everybody was going to get on board, and that was going to really work so well. And it's kind of sad to me. I'm speaking here from my experience in the United States. And during question and answer, I'd be very interested in hearing if this transfers for you. But this is the story of what I've experienced, that we are now in a realm in which there's quite a controversy and fight between people believing in science, people trusting science, and people not trusting science and anti-science. So I guess good for me as a teacher, good for me as thanking you for giving me the opportunity to present this. This is good for me and good for you that this is very relevant now. This is not a 20-year-old story. Sad for all of us is that I wish we weren't in this state. Okay. So back then, 20 years ago, the big challenge for me was I had not seen many courses like this around. Oh, click next slide where it says the big challenge.
Yes, sir.
Yeah, I had not seen many courses like this around. And I didn't know where to start. How do you teach something like this? What's the framework? What's the storyline? So there's many possibilities, and I just was trying to figure out how do you do something like this. So click again to say, is there a right way to teach this course? Okay, is there a right way to do this? Just say yes if you have that slide there. Yeah?
Yes, sir.
Yeah, okay. It says, is there a right way to do this? Yeah?
That's right, sir.
Yeah, so, you know, I don't know that any of us know what the right way to do this is. And it's there's sort of two ends of the spectrum of how you could look at this. One is that I could have retrained myself, learned more about how to be a social scientist, learned more about political science, and come together and bring some very systematic storyline that way. But that was not what was in the cards for me. That was not what I was destined to do. And so the way that I approached it, next slide, how I chose to do it.
Yes, sir.
Yeah. So what I said was, okay, look, I'm just going to do this from my own experience. I had by then been a seismologist for quite a while. I had been working at Weston Observatory. I worked at Columbia's Lamont Doherty Laboratory. I worked at Stony Brook, and I knew something about talking to people after there was a big tragic earthquake. I knew something about talking to people after there was a small earthquake and people wanted us to verify that it really was. I knew how to do this, but if I just completely went that way, it would have been a course on seismology and public policy. And that would not have been stretching myself the way I'm saying I want to stretch myself. Okay, so just as an aside, it's 12:23. Can I talk for another half hour, 40 minutes? Is that good?
Yes, sir. No problem.
Yeah, it's good.
Okay, yeah, and then some discussion. Okay, so let's go with the story. Let's go with the flow. All right. So I said, okay, I'm just going to do this from my own experience. And so searching back then at my own experience, I had become convinced that the way I saw this science and public policy situation was that it seemed to me that a major driving force behind how science and public policy unfolds is an interplay that's all about the way that people relate to certainty and uncertainty in science. So, you know, I suppose this came from my personality, but I suppose it also came from the fact that I do a lot of statistical seismology in my other day job as a regular seismologist. So I think about uncertainty all the time. I teach courses in statistics in geoscience, so I think about uncertainty in geoscience. So I guess uncertainty is kind of my thing. So that's how I kind of came to that. And so all of that led to the fact that the theme for the course became life is uncertain. And the idea behind that is that no matter what we do, there'll always be uncertainty and risks that we have to accept as part of our lives. And where this, I'm sorry, click to so the theme of the course became. And then click again to people are generally uncomfortable with uncertainty. Good.
So the theme of the course became people are generally uncomfortable with uncertainty.
Good. Okay, good. All right. So the other sort of underlying part of that storyline is that it seemed to me that in spite of the inherent uncertainty we all have to accept, that people expect science and technology to eliminate uncertainty from their lives, and that they get disappointed when science fails to do that. So I just want to re-emphasize here, this is how I think things are happening in the science and society realm. I'm, to the students and to you right now, I'm not claiming that this is fact. I'm more telling you and the students, I tell them about this, that this is how I set up a framework for the course that they can critique and discuss with me, and you can critique and discuss with me in any way you want. But this is how I make, you know, when we teach a course, we tell a story. I'm saying, this is my story, and I'm going to go forward with it for the rest of this lecture, and then we can talk about whether you think that's it or not. Next slide. So the story for the underlying storyline for the course is my sense that it's common for people to have grown to expect science and technology to reduce, if not eliminate, uncertainty from their lives, and that they get disappointed. And I think, again, this is what it looks like from my point of view in the United States. Be interested to hear from you. We see a lot in the politics that's happening now, in my opinion, that people even get angry when science fails to do that. And that kind of gets them going into certain ways to relate to science and policy. Next slide. And then if you could click again, it says science is significantly reduced. If you click again and again. Okay.
This is generally a good thing.
Yeah. All right. And it says on the bottom, and recognizing. Yeah.
Yes, sir.
Okay. Yeah. Okay. So this is generally a good thing. I mean, science does reduce uncertainty grandly for the history of science, and I'm not in any way denying that. It's a good thing, but I think that science can't reduce all of uncertainty, and so what happens is that we end up in this situation where people become disillusioned with science when science can't make the exact right vaccine, can't make the vaccine that works for older people and also for very young people, can't solve the pandemic problem, can't predict earthquakes. People get upset with that. And so that's the framework of all possible frameworks that I do for the course. Next slide. And then click again to get the full slide down to I explain to students.
Yes, sir.
Yeah, so there's an interesting intertwined thing that goes on here, is that that's my framework for the course. But the interesting thing that happens is that it also turns out for a framework for the students, because I could just sort of go on and say, hey, you know, I'm the professor, this is the storyline. But I think it's important for me to be honest with the students about what I just said to you in the past few slides. And so I do that. And then we sort of like have a internal experience of the broader science and policy kind of situation, where some students are quite happy with that uncertainty, feel like I'm being very honest about what's happening in life. And other students are not happy with uncertainty. And they just want, tell me what's going to be on the test. Tell me the list of topics I need to know. So, so I think that we kind of like relive the theme of the course as we're doing the course. Next slide. Okay, so that's some philosophy. It says course content, yes?
Yes, sir.
Yeah, okay, so that's some philosophy. Now let's go on to a little more practical matters kind of things, okay? So to understand the relationship between science and public policy. So what I want to do within that philosophical framework, what I want to do as a seismologist, as a geophysicist, as a scientist, is that I want to move it forward so that non-majors can understand the science underlying what we do as scientists, so that they can make better decisions. And so somehow or other, I have to then teach what would somehow be generally very close to a geophysics or earth science for non-majors standard traditional course. And so one possibility is that I could just write down a list of what's everything that I want students to know. I want them to know radiometric dating. I want them to know plate tectonics. I want them to know that the earthquakes happen mostly at the edges of plates. I want them to know evolution. The other thing that can be done, and I did, was I instead chose 5 broad topics. Next slide. And
Yes,
these
sir.
are the 5 topics that I chose. And so the idea behind how I'm doing this is that this list of topics matches that philosophy that I told you about. And that in the process of going through these 5 topics, we will hit upon the things that you would want to teach in a traditional course. So when we talk about Galileo and the church, we'll talk about Galileo and Newton and Newton's laws of motion and how that explains how the planets move. We talk about creation and evolution. We'll talk age of the Earth. We'll talk about radiometric dating fossils. Global warming. We'll talk about electromagnetic radiation as it interacts with the climate, etc. And then initially, hey, guess what, everybody? We had a pandemic. You folks know that better than anybody else because that's how you ended up putting together this online workshop. That's so great. But so skip that for a moment. Then earthquakes in the environment, and that's me talking about things that I know more about and some of my own experience. So those were 4 topics, and then click again where it says recently added. See that?
Yes, sir. Yes, sir.
Yeah. So guess what? We had a pandemic. I had wanted to put population dynamics and the actual human interaction with Earth systems into the course, but I never was able to fit it. And so I'll talk about this a little bit later, but what happened was that in COVID-19, in the 2019-2020 academic year, we all got sent home. And you very quickly turned this workshop online. I very quickly turned this course online. And that enabled me to jump right in and teach this topic on human health and Earth systems. Next slide. So, so what I'm going to do now is I'm going to give a snapshot of each of these topics and show you how it fits into the completeness of the course. Galileo and the Church, Science, Religion, and Public Policy. So what this is to me, and what I teach the students, is that this is, are we on Galileo and the Church, Science, Religion, and Public Policy? Click again where it says scientific reasoning. Yeah? Are we there?
Yes, sir.
Great. Pictures of Galileo and Newton. Yeah?
Yes, sir.
Yeah. So what this is about is that it's there for a lot of reasons. One of the reasons why it's there is it's the church, and there's a lot of history to that, a lot of things that I don't know about. But it's one of the early times where we see science and public policy, church policy, but still it's public policy, clashing. And so it's for some sort of a historical development of the ideas. Let's look at the first time this happened. As we get towards the end of the course and we get all the way to earthquake prediction, earthquake warning, COVID-19 and all that stuff, we're going to see that surprisingly a lot of the ideas that were being struggled with back then we're still struggling with them today. So there's a lot of parallels. The other thing is that figuring out how the planets worked, which then led to Galileo and then Newton's laws of motion and basic physics, all of which I teach in the course. That came from trying to figure out how the planets work. And so there I can teach students about something that goes way back then and is relevant today, and it'll be relevant tomorrow, is what do scientists do? And what scientists do is that they observe things, like position of planets in the sky, and from that try to develop laws. Empirical laws like Kepler's laws, and then theoretical laws like Newton's law. So that's why this is there to get the course rolling. Now, I want to leave time for us to be able to talk, so I'm not going to go through every single thing that I do in the course, but here's a way that you can get an idea of, so when I'm doing that, how do I introduce ideas that we would want to be in a basic science course for non-majors? Click where it says, are you seeing a word cloud? Click again to that. You see a word cloud with Galileo and the heliocentric in the middle?
Yes, sir.
Yep,
Write
okay.
a few keyword on some aspects of this lecture.
Yeah, great, thank you. So this is a word cloud game that they do, and I asked them to write some keywords. So this is kind of interesting. So again, you can just kind of look at this and you could see, you know, philosophy aside, what are the different things that you're really teaching? Laws of gravity, Newton's laws. And interestingly, you can kind of take another spin on this, which is you're seeing what the students think I'm teaching. And good news, which I would panic if it wasn't true, is that what they think I'm teaching, I am teaching. Next slide.
Yes, sir.
Great Lisbon earthquake.
Great Lisbon earthquake.
Yeah, so my understanding of the history here, I'm not a history professor, I'm not a poli-sci professor, but my understanding of the history is a history in which earthquake science plays an important role. This was a very large and very tragic earthquake in Portugal in 1755. It was somewhere between like a magnitude 7 or 8. It generated a tsunami. The tsunami and earthquake caused fires. It was very destructive. And they say, next slide, where it says transition.
Yes, sir.
So historians of science say that this earthquake, which happened in a matter of minutes, changed the world. Now, I'm not a historian, so I can't promise you I know everything about that. But that is the standard philosophy of science story, and that it caused changes in society in which people no longer could just go with old-fashioned religious ideas about acts of God, and it gave an opportunity for science to grow and entering the age of science and reason and the scientific view of understanding of how the world works. So this is a transitional moment. It's also an example which is very relevant for seismology, but I think is relevant for geoscience in general. It's an example of how a single disaster can have a huge effect on the course of human history. And then I think that all of us experienced that in the past 2 years. And now we all have seen how one thing could change an awful lot. And so I'll touch on that in a little while. Next slide. Creation, evolution, and the age of the Earth.
That's right, sir.
Yeah. So here I want to introduce geologic time, radiometric dating fossils. I want people to understand it's geoscience and public policies. I want them to understand that what we as geoscientists bring into the discussion is a sense of time, millions of years. What we as seismologists bring into it is this sense of crossover between those millions of years and human history and 1 minute long large earthquake. So it's about time. So I go through how we learn about creation, how we learn about evolution and the age of the Earth. Now, I don't know what this looks like in India. I don't know what this looks like in other places, but in the United States, this has been a forever controversy in our society in the United States of people wanting, I would argue, not being comfortable with uncertainty, people wanting to teach biblical creation instead of evolution. Anti-evolutionists teach biblical creation in classrooms. So this brings me to a tough point, which is that I'm a geophysicist, I'm a seismologist. I'm not a preacher. I'm not a politician. I don't want to tell people. I mean, I have my own political views, but I don't want to tell students how to think. So I try not to. But I must tell you that when I come to this one, it's hard for me to find the right boundary. And so I try as hard as I can to make sure that I'm teaching my job, what we know as geoscientists, and contrast that as best as I can. But this becomes very political, and it's hard to deal with that in the course. But I do the best that I can. Next slide. Okay, so this says write a few keywords.
Yes, sir.
Yeah, okay. So again, since I do want to leave time for discussion, I see it's 12:43 my time. But what if I talk for another 15 minutes?
No
Sound
problem,
good?
sir.
That'd match it about right, yeah? Yeah, okay.
Yes, sir.
So in that spirit, I don't want to now talk for another hour on what are the things that I cover, but this again is, you can see, obviously, you can hear in this talk, I'm doing a lot of philosophizing, but you're going to want to know, as seismologists, as geophysicists, as geoscientists, you're going to want to know from me. So what do you teach? Teach radiometric dating. In order to teach radiometric dating, I teach about basic properties of matter. I teach about radioactivity, and then I teach how do we know about ages from fossils? How do we know about from sediments? How do we know it from radiometric dating? Okay, so that's what gets covered in that part of the course. Next slide. Okay,
Yes.
other topic, global warming and climate change. So I could say that maybe I don't have to say anything here at all. Yeah, who could teach a course like this without teaching global warming and climate change and teaching about the environment? So I do. What's in this? So what's in this is what if I were to explain what's in this? I could explain. Okay, so in terms of what do I do as a physicist, geophysicist, geoscientist? I'll say a lot of what I end up doing over here is about the atmosphere, but even a lot more about light and electromagnetic radiation and long wavelength, short wavelength, radio, um, um, visible light and how that interacts with the atmosphere. So that's what I teach in terms of the topic content. But this is also a very good place to deal with uncertainty. And I think that a way that you can picture this in your mind is to sort of to follow the IPCC reports over I don't know how long they've been doing them, but something roughly close to the time horizon that I've been teaching this course. And we can see that the idea that humans are causing this has become more and more certain in the eyes of the consensus of the IPCC. So another part of this is that I consult with climate scientists, colleagues of mine. I try to give them a sense of what do we know and what do we not know. And as the years have gone on, there's been more of what do we know. And the reports that have come out very recently have come close to near certainty that in the eyes of the IPCC, Intergovernmental Panel on Climate Change, that humans are causing this. Okay, so I know it's controversial politically. I try not to get into that, but that's what I do. Next slide. And again, so that we will have time for us to chat, and I can hear what your thoughts are on this. This says write a few keywords again.
Yes, sir, that's right. Slide number 21.
Oh, thank you. From now on, I'll give the number. Okay, good. I teach about the issues of climate change, Kyoto, Paris Agreement, how the atmosphere works, as I spoke about in the previous slide. What's not shown over here, because this was just one, this was at the end of one lecture, is in another lecture you would see all about radiometric dating and infrared light and visible light and how atoms radiate things and how that happens in the atmosphere. Okay. Slide 22. Well, this got added in the past year and a half, which is not going to surprise you. And how did that happen? Well, the way that that happened was that we all were sent home, and in many ways, we were there. We were living geoscience and public policy. We were learning science and public policy because how human health and Earth systems interact was just sending us home, putting all of us into quarantines. And I had for a long time wanted to put human health and Earth systems into the course and didn't have time to do it. But this just seemed so important at the time that I just threw it into the course, and I actually knocked out some seismology at the end in order to do that. So technically what was going on here is that people kept hearing Dr. Fauci and others talking about flattening the curve. And flattening the curve is all about mathematical modeling of pandemics, which is almost identical to mathematical modeling of population growth, which is something that I think is important to have in this course, and to see how many billions of people are on the planet in different times relative to what the temperature of the atmosphere was and all of that. So I introduced a whole section of the course on the mathematics underlying. So like my hope, it'd be interesting if I could test that now, was that I knew that a lot of people heard about flattening the curve and they did not know what it meant. And to be honest, I didn't know until I started working on this. As I hope that my students who go through this course will be good citizens, because they'll hear Dr. Fauci talking about flattening the curve and they'll say, I know what that is. Okay, so So I introduced this. I'll have a little bit more to say about that in a couple of minutes. Let me see where I'm going. I see where I'm going. Okay. Okay. But to get back to the larger part of, no, I'm sorry. So I'll have more to say about that, but we introduced this topic, and the students were living the topic that was thrown into the course. Okay. Next topic, slide 23. Yes?
Yes, sir.
Earthquakes in the environment living on an active planet. So, a couple of different things. One thing is that, this is where I feel more comfortable. All of the topics that I've mentioned so far, I'm trained as a seismologist, geophysicist. Those were not topics that I felt I'm super expert in. I get help from other people, climate scientists, geologists, paleontologists. But this is something that I'm comfortable in. And at the same time, what I'm going to say to you in the interest of time is that I'm not going to talk about a lot about this. You can see what I'm doing by looking at this snapshot of the word cloud. And I guess what's my point here? My point is, no surprise. You can see that in my course, there's a lot of the topics of the wonderful lectures that other people are giving in this workshop. And so, yes, I cover all of those things. Earthquake prediction and forecasting fits really well with the uncertainty. Earthquake warning systems fits very well with that whole sort of idea of, oh no, we're not completely blind. Scientists can reduce some uncertainty at the level of earthquake warning. Can't reduce it so well at the level of earthquake prediction. And in between, earthquake forecasting. So I talked about that. Okay. Slide, it doesn't show up so well, but the slide that says plate tectonics explains most earthquakes.
Yes,
and then
sir.
click again to
Yes, sir.
we're down to where it says, but then there are these
Yes, sir.
and then
We are
interplate earthquakes with some arrows. Yep.
Yes,
The
sir.
black arrow. Okay. So I do leave some time in the course in which I just want to see. I do leave some time in the course in which I talk about my own work on interplate earthquakes to give them a sense of what I do myself, and to speak about something that I really am very familiar with. In this part of the course, I teach about plate tectonics, and I teach about how plate tectonics work with earthquakes, elastic rebound, and all of that. Another topic that has been a big deal for me since the beginning of, could we go to slide 25?
Sure, sir. Yes,
Seismic noise, anthropause. Yeah, so if you could click over to slide 26. Okay.
Yes, sir.
And let me talk about that, and then we're going to click back. Click down again. You see a map. Okay, and then click down once more. So I had an experience, and the experience that I had was that while we were all sent home, I got myself involved in this paper that we eventually published in Science with our leader, Tom Lecoq, who was the first author, and 75 other co-authors, and I was one of them. And where we were tracing seismic noise around the world and how that related to lockdown. So while I was transitioning the course over to online, I ended up connecting with 76 seismology friends, and we all worked on this problem of trying to track what we thought we saw in the seismic quieting due to the lockdowns and less human activity. So the way this is shown here is each little pixel line there is noise over several months. The white line is lockdown date, so China's at the top, New Zealand's at the bottom, Boston and Washington, D.C. is in the middle. You see Christmas and New Year's holiday, so blue is quiet. You see Christmas and New Year's holiday as a stripe on the left, and then you see after the lockdowns. So, so there's a seismograph right underneath the classroom where my big 300 students are taking this course. So they were seeing themselves, and they were seeing how science evolves. And so that became part of the course also. If we could go back to slide 25.
Yes,
so
sir.
This is that same work, but updated to a few weeks ago. And this idea that we were seeing this lull in seismic noise was very exciting. It got published in New York Times and Washington Post and TV and a lot of excitement about it. And so I decided that, so this thing got labeled the anthropause, the global reduction in human activity. And this was going to be really great for seismology because we were going to have quiet stations for quite a while. And this was going to be really great for the human race because less carbon dioxide in the atmosphere. And so what I'm showing over here is a very recent update. This is on Boston College campus. And you can see in the black is the seismic noise. And in the red is, well, Apple and Google are watching you. So this is Apple mobility for the Boston area. And these are two sites on the Boston College campus. So it's kind of interesting. You can see what's happening towards the end is only a couple weeks ago, and you can see that. And if you go, I updated it again, and it's even more. So we are very much returned to what it was like before the anthropause. And the interesting thing is, with all the fanfare about how big a deal this was, the quieting, quote, anthropause really only lasted a few months. So there's a lot to think about regarding that. And a lot to think about how seismology is tracing human activity. Okay, slide 26, I guess I spoke about that. Slide 27. So those are two specific things. And more generally, yeah, I'm almost there. I'm almost done. And more generally, these are the other topics that I cover in the topic on earthquakes, the environment, living on an active planet. Okay, slide 28. So again, nothing in this course is intended. Yes. Yeah, says that.
Pardon, sir?
Again, nothing in this course is intended. Slide 28.
Okay, sir. Slide
Yep.
28, yes.
Yeah, good. Okay. So, I mentioned this when I was talking about age of the Earth. And I'll talk for about another 5 minutes. And I was talking about age of the Earth. And I, at that point I said, people have their opinions and some of it is religious and all of that, and that's not my role. But then when I come to something like somebody predicting an earthquake that I think is questionable, this becomes a little bit harder for me because I have a well-informed opinion. So I have to find some way to balance that, hey, I know something about this, with the fact that I want them to think for themselves. And that's a challenge for me in teaching the course. Slide 29. Okay, so what I want to say about this is I want to say, so this is interesting. So I have this philosophy and I have these things that I told you that I teach. It's all kind of interesting to me. And where does this sit in terms of, yeah, but these students are paying to get a science core course, right? And Boston College cares that this is a science core course. The interesting thing to me is that when I sit in other professors' courses, when I listen to audio books, go through entire courses that professors teach in different places, by the time I get to the end, and you can kind of get a sense of over here, it's quite surprising to me how much I have basically covered, sometimes really close to verbatim for quite a while, what's taught in courses with all kinds of other themes. So I've seen courses like this where instead of the theme being uncertainty, the theme was energy and the environment, but it's basically a geoscience course. And one might think that that would go in really different directions. But I guess, you put a geophysicist in front of a class and we kind of teach the same things. I think is good. Okay. Slide 30. So the reason why I put up the introverts thing in the beginning is because I'm an introvert. This class has grown to have 300 students, many requests for overrides. I'm in front of this big classroom, surprise, surprise, with the seismograph underneath it. And by nature, I'm an introvert, and I would, this semester I'm teaching 8 graduate students. Some of you might be listening now. I feel comfortable with that. Another course I'll teach next semester will have 30 students. I'm good, okay? 300 students is a lot for me. And so I feel like, I don't know how all of this has happened to me. I feel like a fish out of water teaching a course like this. I'm certainly not perhaps I might be entertaining to people who are immersed in geophysics here that I'm talking to right now, but I'm not an entertainer to a wide group of young people in college from all different backgrounds, pre-med, pre-law, poli-sci, whatever. But somehow it seems to be happening, and I seem to be doing it. And my reward for 20 years happened a couple of days ago, which, it's important to have high enrollments for the department and all of that. I've just been given permission to hold it to 150 students for when I teach it next semester, and I think that's going to be a good thing. So one other thing that I may have not said to you. Could I go to slide 1?
Just a moment.
Just if you hit a 1, can slide 1? I may have not told you. Do we have slide 1 with the title?
Yes, sir.
And I can give this to our leaders in this workshop, but the URL at the bottom, bit.ly Geoscience Public Policy version 3.0. Starting 3 years ago, I decided that I was doing what I just told you about. But other than the students watching me talk in front of the classroom, there wasn't really any textbook on the storyline I just told you about. So I kind of wrote one in the form of a blog. And it's at that URL, geoscience _ public policy _ v3 _ 3.0 first time I did that was 3 years ago. Right now I'm working on version 4.0. But if you go to that link, you can see my blog, which who knows, maybe someday might be a book. I don't know. We'll just see what happens. But in the meantime, maybe the world doesn't need another book from a seismologist. I don't know. But right now, it's there, almost like a book or the beginnings of a book for the course. And so you fills in a lot of the things that I ran over pretty fast. And then if we could just go to slide 31. Some takeaway?
Yes.
By the way, thank you so much for guiding me through these slides with that technical difficulty I had in the beginning. I think it worked. I'm a little shocked, but I think it works. So I'd like to hear what people think. And here's some things that might help. You could leave this on the screen or not as we talk. This is my last slide. I think it's sad that we're living in this science versus non-science world.
Yes, sir. Yes, sir.
Yeah, good. Can we do better? How can scientists help? What do people think about the way that I've configured the course? Even an introvert can contribute to bringing science to people and people to science. And what are your thoughts on this? So I think I'm going to end with that, and hopefully let's talk. Thank you so much for your time and for walking through me with this during some not so smooth technology. Thanks to everybody.
Thank you, Professor Alan. Your talk reminded me the most stimulating, intellectually reviving conversation between great scientist Albert Einstein and great Indian poet philosopher Rabindranath Tagore on science and religion. Thank you, Alan, for sharing your experience as a teacher and as well as a scientist. Now, may I request our session advisor, Professor Dapeng Zhao, for his remarks. Over to Professor Dapeng Zhao.
Yeah, thank you so much for the nice talk. I just have one quick question. You mentioned the 1755 Lisbon big earthquake.
Yeah.
Can you tell me its focal mechanism? Was it a thrust faulting events or strike slip one?
It's mostly strike slip with a little bit of vertical motion, if I remember correctly. Maybe a lot more vertical motion, maybe like an in-between strike slip and some thrusting. Okay, so there's somewhat of a plate boundary there. It's offshore, not very far offshore. There's somewhat of a plate boundary over there between the African plate and the Eurasian plate.
So it could be it was mega thrust.
Yeah, I think it was more thrust than I said strike slip only because I was picturing it's an east-west boundary, and so it's like clicked in my mind as being a transform fault, but it's not. It's the squeezing, it's the thrusting.
Okay, I see.
I mean, we didn't have seismographs there, but
yeah, I know.
Nonetheless, yeah.
Yeah. Okay. Thank you very much.
Now let me invite our session chairman, Professor Zer Kyle, for his remarks and comments. About to Professor Kyle.
Oh yes, thank you, Santanu. Professor Kaif, you have made us spellbounded. We have had an excellent lecture from an introvert teacher who has taught us history, religion, society, global problem, everything. It was extraordinary lecture. we are always afraid of giving lecture, rather popular lecture to the public for public awareness, which is always, instruction advices from our science and technology department, that it should be, we should raise the public awareness about earthquakes or tsunamis or whatever. And we feel difficulty, how to present to the public. Now you have taught us, yes, you have given us enough, materials, enough thought, innovative thoughts and guidelines. Thank you so much for an excellent lecture. And we have learned really how to connect the public for societal benefit of the science. Thank you so much, Professor Kaya. Thank you.
And as you mentioned that, it just occurred to me, to make everything easier, you now have all the slides. So
yes,
you can post the slides. It's got my web addresses. It's got, people want to read the blog, go over the slides again. You have it.
So will it be okay if you can take some questions from our attendees?
Wonderful.
Yeah. Over to Dr. Antara for question and answer session.
Thank you, sir.
Over to Dr. Antara.
Thank you, sir. First of all, I would like to thank Professor Alan Kafka for his wonderful lecture. So I'm going to read out the questions asked by the participants. So first question is, can there be any temperature change of a region which may be resultant of change in seismic behavior of a region in long term?
Can I take them one by one?
Yeah, this is the first question.
Yeah.
So,
yes. Can I answer that one?
Yes, sir.
Okay. So this is one of those dangerous questions because there's so much uncertainty, but I'm going to start out by saying Greenland. It's more than Greenland. Let's start with Greenland. Getting hotter, the ice is melting. I am not an expert on this, but there have been a lot of papers, and there's a book called Waking the Giant, I forget the name of the author, that argues that the melting of the ice in Greenland is giving us glacial rebound, which is increasing the number of earthquakes. I'm not sure how well that is played out with empirical statistical studies of the earthquakes, but it's not a crazy idea, and some people say that they actually can see the more earthquakes. The question sort of, since I'm not so much of an expert on climate change in terms of temperature, the question was about temperature, it sort of leads me towards a slightly broader question: is things we are doing that can lead to more earthquakes, and fracking and injection wells comes to my mind. When I first started graduate school, I'm 72 years old. That was quite a long time ago. When I first started graduate school and people were talking about injection wells and earthquakes, I thought it was kind of a not very well worked out thing. And nowadays I look at Oklahoma and other places on the earth, and it seems like we're poking the earth. And I don't know what the answer is, but I wouldn't be surprised if the answer is yes. We're heating the planet, and it could induce earthquakes. I guess. I'll leave that to other people to say yes or no, but I think the topic is very well worth it.
Thank you, sir. So the next question is, sir, can we presume that earthquake forecast would be possible or feasible in the near future?
Yeah. So let's do earthquake forecast and earthquake prediction. Okay. So prediction is I tell you the time, the place, and the magnitude. And forecast is I tell you the probability over some long next decade or so. So the enthusiasm over earthquake prediction has, in my experience over the decades that I've been a seismologist, has had a cycle of about 10 or 20 years of optimism and pessimism. So when I first started teaching this course, we were at a pessimistic point where the consensus of seismologists was no way we will ever be able to predict earthquakes. About halfway through, about 10 years into it, we were at a point where people were starting to feel a little bit more comfortable with the idea of talking about prediction. And that I think we're sort of over that peak again. And I think that we're over that peak in the sense that there's now more focus on forecasting. And I think forecasting is something that even a person like me who thinks everything is uncertain, I think our colored forecast maps that we as seismologists put out, there's some reality to them. I think that we're getting somewhere with forecast. I guess forecasting transitioning into earthquake hazards. And then, of course, earthquake warning, technical difficulties, social difficulties. What do you say when a lot of people get the warning and all that? But earthquake warning, I think, is very real. I think we're at about the level of technology and science and social science that earthquake warning is a very meaningful thing for us to be hoping for, and in some cases already doing.
Thank you, sir. Sir, the last question is, sir, you have rightly said that sometimes inability of address the basic scientific challenges like predicting an earthquake may negatively impact the public precaution, public perception. How do you address it as a scientific community?
Okay, so I just want to make sure that I'm understanding the question. So if you could work with me with that, is this saying that if I get up as a seismologist and speak negatively about earthquake prediction, that will make people skeptical about scientists? I think that's what it's being asked. Yeah. Does that sound to you like what's being asked?
Yes, sir. Yes, sir. Yeah.
Yeah, I think that's what's being asked. This has been, I mean, maybe I'm overusing the word tormenting me. This has been tormenting me throughout my entire career. So, you know, we have these situations where the truth of the matter is that we don't know when the pandemic is going to end. And we have these situations as well. Should a scientist say that because that will lead to skepticism? We have these situations where people come along and they make very exaggerated claims about being able to predict an earthquake or predict what the temperature is going to be in 50 years. And sometimes scientists look at it and say, oh boy, that's just too optimistic. So where do you sit in the middle of it? I think that I am one who has more of a tendency to point out what we don't know. And I think the questioner brings up a really good and important point. Maybe I'm helping that, maybe I'm not. I guess we could all hope. I believe in science. If you're at this meeting, you probably believe in science. I guess we could all hope that being as honest and not alarmist as we can, that will ultimately be good for society. But boy, it's a tough question. Thanks for asking.
Thank you, sir. Sir, due to time constraints, we cannot proceed for more questions. Sir, we will send you all the questions through mail, sir. Thank you, sir.
Okay, are we going to end the meeting now?
Last
Yes,
last schedule is vote of thanks. May I request our Dr. Anessa, Dr. Hazarika for vote of thanks, please. About Dr. Anessa.
Okay, should I sign off the meeting now?
Wait for the vote of thanks, please.
Say it again.
Anessa, go ahead, please.
Okay.
So please
Thank
wait
you.
for the.
Sir, wait for the vote of thanks.
Please go ahead, Anessa.
Thank you, Dr. Shantanu Borwa, sir. Good morning from CSIR NAIST India. On behalf of the entire organizing committee of IVW GST 2021, I, Anvesha Datta Hazarika, extend my sincere thanks to the speaker of our today's session, Professor Alan Kafka, for kindly accepting our invitation and for sharing his valuable experiences and insights with us, and for delivering such an intriguing lecture on the topic Reflections on my past 2 decades of teaching Geoscience and Public Policy, an undergraduate science course for non-science major. Once again, a hearty thank you. I take this opportunity to specially express my deep regards and gratitude to our Honorable Director, Dr. G. Narahari Shastri, for always encouraging us and providing opportunities to organize such events. I also express my heartfelt thanks to all our honorable resource persons, International Advisor of this workshop, Professor Andrew Michael, and Session Advisor, Professor Daping Zhao, for their immense guidance and support towards this event. I also thank Professor J.R. Kayal and Dr. Saurabh Borwa for being constantly connected with this program and for their unfaltering support and valuable suggestions. My deep sense of appreciation and thanks to all the participants who chose to be live with us and attended with great enthusiasm and made it a successful event. Last but surely not the least, I thank the convener of this workshop, Dr. Shantanu Borwa, for his immense dedication towards this workshop and for giving us such a good platform to interact with the renowned personalities across the world, and to the technical support team for helping us webcast this event through the MS Teams. We also fervently desire your presence for the next technical session of this virtual workshop, which will go live today at 7 p.m. Indian Standard Time. The speaker for the next session is Dr. Daniela Kuhn from Norwegian Seismic Array, Norway. She will deliver a talk on probabilistic moment tensor inversion, examples from Europe. With this, I conclude today's session. Once again, thank you all for being us in this morning. Have a wonderful day ahead. Thank you. Namaskar.